This question is to solve the probability problem involving three events, x, y, and z. It demonstrates the application of the principle of inclusion and exclusion to calculate the probability of at least one event occurring. Let x, y, and z be three events. Suppose the probability of x is 1/3, the probability of y is 1/3, and the probability of z is 1/3. Also, the probability of both x and y occurring is 0. The probability of both y and z occurring is 0. The probability of both x and z occurring is 1/9. What is the probability that at least one of the three events x, y, or z occurs? First step is to apply the principle of inclusion and exclusion. To find the probability that at least one of the three events happens, we use the standard rule. Add the individual probabilities of x, y, and z. Then subtract the probabilities of the pairs x and y and z, and x and z. Finally, add the probability of all three events happening together, which is x and y and z. Now substituting in the given values. 1/3 plus 1/3 plus 1/3 gives 1. Subtracting 0 for x and y, 0 for y and z, and 1/9 for x and z, we are left with 1 minus 1/9, which equals 8/9. We then add the probability of all three happening, which we will find in the next step. So the total is 8/9 plus the unknown value for x and y and z. Next step is to determine the value of the three-way intersection. Since the three-way event, x and y and z, is a subset of the pairwise event x and y, and since the probability of x and y is 0, it follows that the probability of all three happening must also be 0. This is because the smaller event is fully contained in an event that has 0 probability. So, the probability of x and y and z is 0. Next step, adding that 0 into the earlier total, we find that the probability of at least one of the events x, y, or z occurring is 8/9. That is the final answer. A frequent student mistake is to assume that when the probability of two events together is 0, it means they are completely disjoint or impossible to happen together in every sense. In fact, the event might not be empty. It might just be so rare that its probability is 0. So always handle 0 probability intersections with care and check if subset logic applies. In problems like this, always write out the inclusion and exclusion rule clearly. If you see a 0 probability in a pairwise event, check whether a more complex event is a subset of it. This often helps you conclude that its probability must also be 0. This is the key insight that unlocks the solution efficiently. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.